How do you know the output of a program without running it on an IDE? Hi coders! Welcome to CS Time channel. In this video, I will talk about tracing tables. Stay tuned!
Have you ever heard about dry run? Dry run in computer science or programming is the process of a programmer manually working through their code to trace the value of variables. And one way to do it is by involving a trace table. A trace table usually contains all the variables a program contains. So, trace tables that allow programmers to test the value of variable as each line of code is executed. This is also to make sure the programs or the algorithm perform the required task correctly. And it can also be used with flowcharts, pseudocode, or even real code. It can also be used to discover the purpose of an algorithm by showing output data. Let's see an example. Here you are given a pseudocode and you are asked to display the output of this pseudocode. And you are given a sample or data is 5. So at first, you have to create a table. The table should contain all the variable here. We have number as well as the condition to check as well as the output. So your table will look like this. As soon as you are done with this, now you can run your pseudocode. We start from input number. In this case, we want to input 5. And then we enter the if number equal to 0. It's false. Since it is false, the statement after if will not be executed. It will go to else if. Number, which is 5, greater than 0, the answer is true. Since it is true, then the value here will be executed. Since it asks to display it under output, then we will put 5 here according to the number, and this statement here will be written here. Now let's see the second example. You are given a pseudocode like this and you are given data is 6. As I mentioned earlier, your job is to put all the variable in your code as well as the condition in your code into a table. So it will look like this. We have sum, we put it here, we have count, we have condition to check here, and then we have another condition to check as well as output. Now let's run this code. Sum is 0. Count is 1, 2, and div 2. Our n is 6. So 6 div 2 is 3. So we will do the looping from 1 up to 3. So our count is 1. If n, in our case we have 6. If n, which is 6, mod count equal to 0 is true, then we will execute this one. Sum, which is 0, plus count. Here, 1. And then we put it under sum. We put 1 there. And then we go to this, go back to the beginning of the looping. Now our count is 2. Our count is 2. We enter again the looping. If n, which is 6, still 6, mod count 6 mod 2 equal to 0, in this case is true. Since it is true, then we will execute this. We have sum, which is 1, plus count, which is 2, become 3. We put it under sum. Our sum now is 3. Now, we read the end if, read the end loop, it will take us back to this. Now, our count is 3, increased by 1, so our count now it become 3. We enter the if n, which is 6, mod count, our count is 3. 6 mod 3 equal to 0? Yes, the answer is true. Since it is true, it will execute this. Our sum, which is 3, plus count, which is 3, so it's 6. So sum is 6 now. Our sum is 6. And then we go here, we go back here. Now, it's already quit the looping because it's already fulfilled. We continue to this. If sum equal to n, our sum is 6. 6 equal to 6, true. Then output perfect. Under here, we will write perfect. Let's see the last example. You are given a tracing table like this. The process is going to be the same whether you are given a pseudocode, you are given a program, or tracing table. And then you are given a data x equal to 2 and n equal to 4. So the step is the same. You have to create a table first and then put all the variables as well as all the condition to check in the looping and also the output if any. Now here is the tracing table. X and is inside as well as P, and we have the condition. We don't have output here as the flowchart doesn't require it. So we will start reading the flowchart from here. Our X is 2. Our N is 4. Our P is 1. And then now we enter N greater than 0, which is true. Since it is true, we will run this. P was 1 times X is 2. 1 times 2 is 2 and we put it on P. So our P now is 2. N is 4 minus 1 is 3. We put it under N. So N now is 3. And then go back to this. When we go back to this, then we will read again the checking. N, which is 3 greater than 0, true. Since it is true, we will execute again this one. Now our P is 2 times X is 2, which is 4. We put it under P. And then the N, which is 3 minus 1 is 2. We put it in the N. Now we go back to this one. Check again. N greater than 2. N is 2 greater than 0. Then true. Since it is true, then we will execute again this. The P is 4 times X, which is 2. So it's 8. Put it in the P itself. Now the N, which is 2 minus 1 is 1. And then we put it in the N itself. And then we go back to this. We check again this one. N, which is 1 greater than 0, true. We put it through there. And then, since it is true, again, we have to execute this one. Our P is 8 times 2 is 16. And then N is 1 minus 1 becomes 0. Put it there. Now we go back again to this and then we will test the condition. Our N is 0 greater than 0 is false. So here it's false. Since it is false, we will execute the program here. The program here is P. P is 16. So it's 16. That's the end of the program. Now we will convert one of the example that I gave in the tracing table, and we will prove whether our tracing table is correct. I already prepared the code, so I will just paste it here to save the time. The first example that we did is this. So we ask a number to input and then we check the number. If it's equal to 0, then we tell that the number is not positive nor negative. And if the number greater than 0, then we display its positive. Otherwise, we display its negative number. And then we test it. Okay, we enter the number. Say I enter 10. Then the result is 10 is positive. Like that. Well, If you learned something from this video, please subscribe and like for more videos. Thanks for watching.